What's going on, everybody? Welcome back to my YouTube channel. Let's solve this math question that says find the value of n for which 3 to the n plus 2 to the n is equal to 35. Well, before solving this question, there is something we need to put at the back of our mind, and it is n is a natural number. So put that into the back of your mind that n is a natural number. So our first step will be to take 3 to the n. So take 3 to the n, divide it by 3, and also multiply by 3. The reason is because when you divide n by 3 and multiply by 3, the 3 and this 3 can cancel out, leaving n. So we still have 3 to the n, which means nothing has really changed. We're going to be doing the same thing to this 2 to the n. So we have plus 2 to the n is the same as 2 to the n over 3 times 3. Very good. Equal to 35. Now our next step will be for us to apply the law of indices that says when I have a to the m times n, this can be written as a to the m all raised to the n. That means we're going to be writing this and this in this form. So this will be 3 to the n over 3 all raised to the 3 plus 2 to the n over 3 all raised to the 3 equal to 35. Very good. Now our next step will be for us to apply substitution by saying let what is inside of this bracket, which is 3 to the n over 3, be equal to a, and b, which is what is inside of this bracket, so 2 to the n over 3, be equal to b. So that means wherever I see this expression, I'll put a, and whenever I see this expression, I'll put b. So this will be a to the 3, so a to the 3 plus b to the 3 equal to 35. Very good. Now notice that we have an expression in the sum of two cubes. An expression in the sum of two cubes has property. For example, when I have x cubed plus y cubed, this is written as x plus y times x squared minus xy plus y squared. Very good. So that means we can write this in this form. And writing it in this form, we have a plus b times a squared minus ab plus b squared, which gives this expression equal to 35. Very good. Now our next step will be for us to write the factors of 35. So 35 is same as 1 times 35. 35 is also same as 5 times 7. Well, there is something you need to know. You notice that I focused on just the positive factors of 35 and not the negative. The reason is because whenever you are solving a question that has to do with natural numbers, we focus on the positive. Very, very important. And also know that bringing a and b into the picture, we should know that a and b are positive integers. Very, very important that we know this. So focus on the positive factors of 35. All right, so we've written down the factors of 35. That means we're going to be writing our equation again. So we have a plus b times a squared, or this is supposed to be a squared, minus ab plus b squared. Wait. So we've written down the factors of 35. So rewriting this expression, we have a plus b times a squared minus ab plus b squared will be equal to, focus on the first factor we wrote, which is 1 times 35. And then let's rewrite this again. A plus b times a squared minus ab plus b squared will be equal to, the second factor we wrote is 5 times 35. So focusing on the first factor, we can say this is case 1, and then call this other factor case 2. Very good. And now let's focus on case 1. So case 1. Our case 1 is where we have a plus b times a squared minus ab plus b squared to be equal to 1 times 35. Very good. Well, there is a truth to this, that a plus b, which is this factor, a plus b, is smaller than a squared minus ab plus b squared. So a plus b is smaller than a squared minus ab plus b squared. That is the case, always the case. So that means this smaller factor will be paired to this smaller factor of 35, and this bigger factor will be paired to this bigger factor of 35. And so the smaller factor, which is a plus b, is equal to the smaller factor of 35, that is 1. And then the bigger factor, which is a squared minus ab plus b squared, will be paired to the bigger factor of 35, which is 5. Very good. Now, this factor, I'm going to be calling it equation 1. Very, very important. So how do I get equation 2? I'll get equation 2 from here by taking the square of both sides. So I'll take the square of a plus b, which is the left-hand side. I'll also take the square of 1. And now expanding the left-hand side, we have a squared plus 2 times a times b, which gives 2ab, and then plus b squared. Very good. Equal to the right-hand side, 1 squared is 1. So this is equation 2. Now what we're going to do here will be for us to subtract equation 2 from equation 1. That means subtract equation 2 from equation 1. And what is equation 1? Equation 1 is, the left-hand side is a squared minus ab plus b squared. That's equation 1. Minus the left-hand side of equation 2 is a squared plus 2ab plus b squared. Now let's go to the right-hand side. The right-hand side of equation 1 is 35 minus the right-hand side of equation 2 is 1. Very good. And now let's open up the bracket using this minus. So we have a squared minus ab plus b squared. So this becomes minus a squared. So minus a squared. Minus times plus is minus 2ab. Minus times plus is minus b squared. Very good. So this is equal to 35 minus 1 is 34. Now let's simplify what we have on the left-hand side. So notice that a squared minus a squared will be gone, and b squared minus b squared will be gone. So we are left with negative ab, negative 2ab. So negative ab, negative 2ab gives negative 3ab. And this is equal to 34 on the right-hand side. Now notice this expression we have. The left-hand side is negative, while the right-hand side is positive. An expression like this, where we know that a and b are positive integers, both sides must have the same signs. But since these have different signs, that means we're going to be rejecting this. So we're going to be rejecting this. Very good. Now we're going to be focusing on our case 2. So case 2. Our case 2, we know that we have a plus b times a squared minus ab plus b squared to be equal to the second factor of 35, which is 5 times 7. Very good. Now remember the truth statement that we said, that a plus b is always smaller than a squared minus ab plus b squared. So that means the smaller factor go with the smaller factor of 35. The bigger factor go with this bigger factor of 35. Very good. So we take the smaller factor, which is a plus b, to be equal to 5. And we take the bigger factor, which is a squared minus ab plus b squared, to be equal to 7. Very good. And just like we did, this will be equation 1. And how do we get equation 2? We do that by taking the square of both sides. So the left-hand side is a plus b. I'll take the square, equal to the right-hand side is 5. I'll also take the square. Now expanding the left-hand side, we have a squared. So this is a squared plus 2 times a times b, that's 2ab, and then plus b squared. Very good. This is equal to 5 squared is 25. Now remember what we did. We're going to be calling this equation 2. And now we subtract equation 2 from equation 1. Equation 1, we have a squared minus ab plus b squared. That's the left-hand side of equation 1 minus the left-hand side of equation 2, which is a squared plus 2ab plus b squared. Now let's focus on the right-hand side. The right-hand side of equation 1 is 7, and the right-hand side of equation 2 is 25, so minus 25. Very good. So now let's open the bracket. So we have a squared minus ab plus b squared minus a squared. Now minus times plus is minus 2ab. Minus times plus is minus b squared. And this is equal to 7 minus 25 is negative 18. Very good. Now notice that a squared minus a squared will be gone, and b squared minus b squared will be gone. So minus ab minus 2ab gives minus 3ab. And this is equal to the right-hand side minus 18. Now notice that we have the same signs on both sides. We have negative on the left, and we also have negative on the right. So this is accepted. So we're going to be accepting this. Now what we're going to do will be, the negative can cancel out negative from both sides. So leaving behind 3ab to be equal to 18. And in order to get the value of AB, all I have to do will be to divide both sides by 3. 3, which is the coefficient of AB. So 3 can cancel out 3, leaving behind AB to be equal to 18 divided by 3 is 6. Very, very good. Now, I'm going to be keeping this. You know, this is a product of A and B. So I'll say the product of A and B, product, which is represented as P, is equal to 6. That's the product, AB. Now, sum of A and B, let's use S to represent that. This is equal to, let me show you real quick. Very good. The sum of A and B, which is A plus B, is 5. So let's use that there. So we got the sum of A and B to be 5. Why? I want to solve this together using a quadratic equation in terms of x. So the quadratic equation is x squared. It has a formula. I'm going to be using the formula. X squared minus the sum of roots, which is s, followed by x, and then plus the product of roots p equal to 0. So this is the formula for writing the quadratic equation. So now writing out the quadratic equation, we have x squared minus s, which is the sum of root is 6, so 6x. Hi. So we have the sum of A and B to be 5. Now, we're going to be using this to draft out a quadratic equation. There is a formula we use to get a quadratic equation, and that is x squared minus the sum of roots, x, plus the product of roots, p, which is equal to 0. So this is a formula we use to derive quadratic equation. So this is x squared minus s. What is s? Sum of root is 5. So 5x. And then plus p. P is the product of root, which is 6. Equal to 0. Very good. And the most interesting part of this quadratic equation is that it can be factorized. So let's go ahead and factorize it. So first things first, we're going to look for the coefficient of 6. The coefficient of 6 is 3 times 2 gives 6. And so since we're going to factorize, that means we're going to open up 2 brackets. Very good. 2 parentheses multiplying each other. And there are x squared here. So this is x times x, which will result to this x squared. And now I need to know what will be here. I can call this, let's say P, and call this Q. Very good. Equal to 0. So what is P and what is Q? Well, I'll focus on 6. I'll focus on 6. So what are the factors of 6? The factors of 6 are 3 times 2. 3 times 2 gives 6. That's true. Now, another factor is negative 3 times negative 2 gives 6. Now, which of these 2 factors can I add to give negative 5? Well, when I add the first factor, which is 3 times 2, this gives 3 plus 2, which is 5. That is not negative 5, so we're going to be rejecting this. Now, what about negative 3 times negative 2? So adding them, negative 3 plus negative 2 gives negative 5. So this is a tick. So that means my P will be one of these factors, negative 3, and my Q will be the other factor, which is negative 2. Let's put them here. So this will be x plus P. P is negative 3. So let me put that. Very good. And then x plus Q. And what is q? Q is negative 2. So let me put that there. Very good. And this is equal to 0. And this is simplified into x plus times minus is minus 3 times x plus times minus is minus 2. Very good. Equal to 0. So we have two cases, which are, the first case is x minus 3 equal to 0, or the other case is x minus 2 equal to 0. Very good. And to get the value of x from here, we're going to move negative 3 to the right. And when we do that, negative 3 becomes positive on the right. Do the same thing here. We're going to be moving negative 2 to the right in order to get x. And when we do that, negative 2 becomes positive on the right. Very good. Remember that we got this from these two equations, which is a plus b equal to 5 and ab equal to 6. Now notice that these two equations are symmetric, which means if I interchange the positions of a and b, I'm still going to be getting the same results. So which means the value of a and b are interchangeable. That means a can be 3 and b can be 2, or a can be 2 while b can be 3. Very good. So now let's use these values of a and b to get the original question we're asked to find, which is n. So we're going to state recall here. Recall that we said 3 to the n over 3 be equal to a, and we said 2 to the n over 3 be equal to b. And now let's try for the first one. So 3 to the n over 3 is equal to a. What is a? A from here is 3. Very good. Very good. Now, notice that 3 to the 1 will also result to 3. Very good. And since the bases are the same, what I'm going to do will be to equate powers. So equate powers. And when I equate powers, I have n over 3 on the left to be equal to the power on the right, 1. And when I cross multiply, you see that n will be equal to 3 as a result. Now we can also test for b, which is what we have here. So this is 2 to the n over 3 equal to b. And what is b? b is 2. And we know that 2 to the 1 is same as 2. Since the bases are the same, we're still going to equate powers. So equate powers. The power on the left is n over 3 equal to the power on the right, 1. And when we cross multiply, you see that n is also equal to 3. Very good. Now, let's use this. Let's use this. So this is 3 to the n over 3 equal to a. And what is a from here? A from here is 2. And 2 to the 1 is 2. Now, there's something you need to know. Since n is a natural number, it is required that the both sides of the equation have the same base. But looking at this, they are not of the same base. So we're going to be rejecting this. And if we also try this for 2 to the n over 3 equal to b, b here is 3. Now notice that there are not the same base, so we reject this. So the only valid solution for n is equal to 3. Now let's check if 3 is actually the correct answer. The original question is given as 3 to the n plus 2 to the n equal to 35. Now let's substitute n here. So 3 to the n is 3 plus 2 to the n is 3. Will this be equal to 35? Now 3 to the 3 is 27 plus 2 to the 3 is 8. Would this be equal to 35? Now let's see. 27 plus 8 is 35. And this is equal to the right-hand side, 35. So we have the left-hand side to be equal to the right-hand side, which means that the correct and only valid solution for n is 3. Very good. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care. I'll do my normal tradition. Thank you, Jehovah. I'll write there for the same line. Very good.